you have seen the movie The One? If not, then please watch it. Not a hardcore science fiction, but an action movie with fast storyline. Produced, directed, and written by James Wong, and lead cast was popular action hero Jet Li. The idea in the movie was simple but fascinating. In the movie, there isn't just one version of a person. There are many. Different versions living in different universes. At first, it sounds like pure science fiction, just another Hollywood concept. But then I discovered something surprising. Some physicists have actually discussed ideas that sound strangely similar. Not because they wanted to create a cool story, but because modern physics started asking strange questions about reality itself. What if our universe is not the only universe? What if space is so enormous that somewhere out there, another Earth already exists? What if every possible outcome of reality happens somewhere else? And what if the universe we know is just one tiny part of something much bigger? This idea is called the multiverse. Now, to be clear, there is still no direct proof that parallel universes exist. But what makes this topic fascinating is that some of the world's most respected physicists, including Michio Kaku, believe the idea is serious enough to study. So in this video, let's explore the multiverse, not with complicated mathematics, but in the simplest way possible.
To understand why scientists even started thinking about the multiverse, we first need to talk about quantum physics. Now, don't worry, this is not going to be a complicated physics lecture. In fact, the strange thing about quantum physics is that even many physicists admit it feels weird. Quantum physics studies the smallest things in the universe, particles smaller than atoms. And when scientists began studying this microscopic world, they discovered something shocking. At very tiny scales, reality doesn't behave normally. Imagine throwing a ball. In everyday life, you can predict where it will land. Everything seems solid and logical. But quantum particles don't behave like normal objects. Instead of acting like tiny balls, they behave more like possibilities. A particle can exist in multiple possible states before we measure it, almost as if nature itself hasn't fully decided yet. And this is where things start becoming strange. There's a famous experiment called the double-slit experiment. Scientists fired tiny particles toward a wall with two openings. If particles behaved normally, they should pass through one slit or the other. But somehow, they behaved like waves, as if each particle explored multiple paths at the same time. Even more strangely, when scientists tried to observe which path the particle actually took, the behavior changed. Just the act of measurement affected the outcome. This confused physicists for decades, because it raised a terrifying question. What if reality is not as fixed as we think? Some scientists believed quantum physics was simply incomplete, but others, including physicist Hugh Everett III, proposed a much stranger idea. What if every possible outcome actually happens, but in different universes? In one universe, one outcome becomes real. In another universe, a different outcome happens instead. And according to this idea, reality may constantly split into countless parallel worlds. This became one of the foundations of the modern multiverse concept.
So far, we've talked about the idea that reality might split into many possibilities through quantum physics. But there's another version of the multiverse that is even bigger, and in some ways, easier to imagine. It's called the bubble universe theory. To understand it, imagine blowing soap bubbles into the air. Each bubble is separate. Each one has its own shape, its own boundary, its own tiny world inside it. Now, imagine something unimaginable in size, a vast cosmic ocean where gigantic universe bubbles are constantly forming. According to some cosmologists, our universe may be just one of those bubbles. Everything we know, Every galaxy, every star, every planet, every human in history could exist inside just one tiny cosmic bubble. And beyond it, there may be countless others. This idea comes from studies about the early universe and the Big Bang. Scientists discovered that right after the Big Bang, the universe expanded incredibly fast, faster than the speed of light. This event is called cosmic inflation. But some physicists believe inflation may never completely stop. Instead, while inflation ends in one region, creating a universe like ours, it continues elsewhere, producing more and more universe bubbles endlessly, like boiling water creating bubbles again and again. And here's where it becomes truly fascinating. Other bubble universes might not be exactly like ours. In another universe, gravity could behave differently. Time could flow differently. The laws of physics themselves might change. Some universes may never form stars. Some may collapse instantly. And some could perhaps support forms of life we cannot even imagine. Physicist Michio Kaku often describes our universe as just one tiny bubble floating in a much larger reality. And if this idea is true, then our universe may not be the entire cosmos at all. It may simply be one small neighborhood in an infinite multiverse.
When people hear the word multiverse, one name appears again and again: Michio Kaku. But interestingly, Kaku did not invent the multiverse theory. His role is different. He became one of the most important scientists explaining these complex ideas to ordinary people. Kaku is a theoretical physicist, which means he studies the universe using the language of physics and mathematics. Much of his work is connected to something called string theory. Now, string theory itself is incredibly complicated, but the basic idea is surprisingly simple. Instead of particles being tiny dots, the theory suggests they may actually be tiny vibrating strings of energy. Different vibrations create different particles, almost like different musical notes coming from the same instrument. And when physicists developed these theories further, something strange appeared. The mathematics seem to suggest that our universe might not be the only one. In some versions of string theory, reality could contain many universes existing together in higher dimensions. This is one reason why Kaku often talks about the multiverse. He believes modern physics is slowly opening the door to possibilities that once sounded impossible. But what made Kaku famous was not just his research. It was his ability to explain mind-bending ideas in a way normal people could understand. While many scientists speak only to other scientists, Kaku brought these ideas into documentaries, interviews, books, and television. He talked about parallel universes, higher dimensions, wormholes, time travel, not like fantasy stories, but as serious scientific possibilities worth exploring. At the same time, Kaku is careful about one important thing. He does not claim the multiverse has been proven. In fact, there is still no direct evidence that other universes exist. But according to Kaku, physics has reached a point where asking these questions is no longer science fiction. It has become part of real scientific discussion. And maybe that's what makes the multiverse idea so fascinating. Not that we already have all the answers, but that modern physics has made the question itself impossible to ignore. As fascinating as the multiverse sounds, not everyone in science accepts the idea. In fact, some physicists strongly criticize it. And their criticism begins with one simple question. If other universes exist, where is the evidence? This is the biggest problem with the multiverse theory. Right now, no one has directly observed another universe. No telescope has seen one, no experiment has confirmed one, and for many scientists, that creates a serious issue. Because science is not just about interesting ideas. A scientific theory must eventually be testable. Some critics argue that the multiverse may be impossible to test at all. If other universes can never interact with ours, then how could we ever prove they exist? Physicist Roger Penrose has criticized parts of multiverse theory, arguing that some versions rely too heavily on speculation instead of observable evidence. Others worry that the idea becomes too convenient. For example, our universe appears strangely perfect for life. The laws of physics seem finely balanced. Some scientists use the multiverse to explain this. They argue that if countless universes exist, then naturally at least one universe would have the right conditions for life, and we happen to live in that one. But critics say this explanation avoids deeper answers instead of solving them. They argue that saying infinite universes exist can sometimes feel less like science and more like philosophy. Even some supporters of the multiverse admit there's a danger here. If a theory can explain everything, then maybe it explains nothing. And yet, despite all the criticism, the multiverse idea refuses to disappear. Because many of the equations in modern physics keep pointing scientists back toward these strange possibilities. So today, the multiverse remains somewhere between science, philosophy, and imagination. Some physicists believe it may become one of the greatest discoveries in human history. Others believe it may eventually be rejected completely. But either way, the debate itself reveals something fascinating about science. Science is not a collection of final answers. It is humanity constantly questioning the nature of reality itself.
The multiverse may sound like science fiction, a concept created by movies and imagination. But what makes it fascinating is that modern physics keeps bringing the idea back into serious discussion. From quantum mechanics to cosmic inflation to theories about higher dimensions, scientists continue discovering hints that reality may be far stranger than we once believed. At the same time, it's important to remain honest. Right now, there is still no direct proof that other universes exist. The multiverse is not an established fact. It is a hypothesis, one of the most controversial ideas in modern science. Some physicists believe it could eventually transform our understanding of reality forever. Others believe it may turn out to be a beautiful but ultimately incorrect idea. And maybe that uncertainty is what makes this topic so powerful. Because throughout history, humanity has repeatedly discovered that the universe is much bigger, stranger, and more mysterious than we imagined. We once believed Earth was the center of everything. Then we learned we orbit the sun. Later, we discovered our sun is just one star among billions in a galaxy, and our galaxy is only one among trillions. So perhaps the real question is not, is the multiverse real? But rather, how much of reality have we still not discovered? Maybe someday, future generations will look back at our understanding of the universe the same way we look back at ancient astronomy today. And maybe the universe we call home is only a tiny part of something infinitely larger. For now, we simply continue asking questions. Because science begins where certainty ends.